Okay, everyone, look at this other problem, which is for practicing function continuity number 3. You can see in here that this is a function that we have defined. It's been defined for us. For the x is smaller than 1, this x is 1. For the x is smaller than 1, our function is x squared. And for the x is bigger or equal to 1, the function is 2. So let's first find the f of 1. The amount of function in the point 1 includes here, because this includes x equal to 1. This would be 2. And the limit of fx, if x goes to 1, from the x's bigger than 1. Let's from the x's bigger than 1. So if I go to this side, again I'm dealing with this part, which will be again obviously 2, because I'm dealing with, this is actually the amount of function in this part. And then limit of fx for the x's that are going towards 1, but x's that are smaller than 1 from the left side, smaller than 1, it's actually f of, it's actually limit of, is limit of x squared when x goes to 1, and it will be 1 square, which is actually 1. So as you can see, the left limit and right limit, they are not equal, therefore definitely the limit does not exist, so the function is not continuous, period. So one of the limit of fx when x goes to 1 from left side does not equal the limit of fx when the x goes to 1 from, so because then for the limit does not exist, so the continuity also does not exist, so this is not continuous, this is discontinuous. So let's draw it and see how it looks like. Actually at point 1, for the x's bigger than 1, so for these x's the function is 2, and of course there is a point, a dark point here, because this exists in here. At the point 1 my function is actually 2, and for the x's bigger than 1 is also 2, and for the x's smaller than 1, this is actually how my function would be. The limit of it, of course, for this point it would be 1, but the function does not exist here, so it's going to look like this, and we know x squared looks like this actually. Yeah, so this is my function. This is a function that is discontinued at this point. There is a break here, there is a separation in here, so I know that is not continuous. If I want to look at the graph, I can say, of course, for the x's smaller, for the x's bigger than 1, so limit of fx for the x's bigger than 1, it will be here, it will be going towards the 2, so it's just going towards this point. And for the x, so it will be actually 2, as we have found before. And the limit of fx for the x's going to 1 from the smaller x's, like these x's, it will go here, and it will go here, it will go towards the point 1, which does not equal this. Therefore we can also see it in the graph that is not continuous.